Welcome back. This is where networking stops being about cables and starts being about APIs. In Lesson 56, Stage 8, we're diving into cloud networking across the big three: AWS, Azure, and GCP. The fundamentals you already know, subnets, routing, firewalls, they all still apply. What changes is how you build them, and that's exactly what we'll unpack together. Here's the path we'll take together. First, the building blocks: VPCs, subnets, and route tables, your cloud equivalent of VLANs and routing tables. Then we'll layer on gateways and the two firewall models, security groups versus NACLs, and trace how traffic actually flows. From there, we connect things up: VPC peering, transit gateway, and direct connect for hybrid links. And finish by stitching it all into real multi-cloud reference architectures. Before we dive in, let's anchor everything you already know to its cloud counterpart. Your office LAN becomes a VPC or VNet, still your private space, just defined in an API instead of patch panels. VLANs at the switch become subnets pinned to availability zones. Your edge router turns into an internet, VPN, or NAT gateway. Your NGFW splits into security groups and NACLs. And that F5 in the rack becomes a managed ALB or NLB. Same primitives, different ownership. You're configuring with calls, not cables. Now let's put those primitives into a real layout. Here's a single VPC carved from 10.00/16, stretched across two availability zones for resilience. Each AZ gets a public subnet. That's where your internet-facing pieces live. The NGFW, the load balancer, a NAT gateway for outbound, and a bastion for jump-in access. Behind them, private subnets hold your apps, databases, and cache, with no direct path to the internet. The pattern is identical in Azure and GCP, only the labels change. Now, how does traffic actually move in and out of that VPC? Through gateways, and there are four flavors worth knowing. The IGW is your bidirectional door to the public internet, stateless and free, one per VPC. The NAT gateway is outbound only for private subnets. Think of it as a one-way valve, managed for you but billed per hour and per gigabyte. The VGW terminates an IPsec tunnel to your on-prem, the cloud equivalent of your old site-to-site VPN concentrator. And the transit gateway is the hub and spoke router that stitches many VPCs and on-prem together, tying it all together. Route tables. Each subnet has exactly one, mapping destinations to a next hop. Local stays inside the VPC, 0.0 points out to either the IGW or the NAT. And that single choice is what makes a subnet public or private. Once traffic gets through those gateways, you've got two layers of firewall waiting. And you really do want both. Security groups wrap around the instance itself, like a host-based firewall on each ENI. They're stateful, allow only, and deny by default inbound, exactly how you'd build per-tier rules for web, app, and database. NACLs sit one layer out at the subnet boundary. They're stateless, so you write both directions explicitly, but they support explicit deny, which makes them perfect for blacklisting known bad IPs across an entire subnet. Rule of thumb: security groups do the real work. NACLs are your belt and suspenders. Now that traffic is locked down inside a VPC, the next question is how VPCs talk to each other. Peering is the simple option, a direct, point-to-point link between two VPCs, low latency and cheap, just like running a crossover cable between two switches. The catch is it doesn't scale. 10 VPCs means 45 peerings, and there's no transitive routing. So A can reach B, and B can reach C, but A still can't reach C. Transit gateway flips that into a hub and spoke. Every VPC attaches once to the hub. Routing is transitive by default, and you can scale to thousands. You pay a bit more and add a hop of latency, but past a handful of VPCs, it's the only sane choice. Once VPCs talk to each other, the next frontier is talking back to your own data center, the hybrid cloud problem. You've got three realistic options. Site-to-site VPN is an IPsec tunnel over the public internet. Quick to stand up, cheap, but capped around 1.25 gigabits per tunnel on AWS and subject to whatever the internet feels like that day. Direct connect, ExpressRoute or interconnect is the grown-up answer. Private fiber from your cage to the provider, 10 or 100 gig, consistent latency, but you're paying port fees and waiting weeks for the cross-connect. And SD-WAN sits in the middle. Extend your existing branch fabric into the cloud. Optimize over whatever ISP you have. Ideal when you've got dozens of sites and cloud is just one more node on the overlay. Now, here's the slide I wish I'd had when I started jumping between clouds. The concepts are identical across AWS, Azure, and GCP. Only the marketing names change. A virtual network is a VPC in AWS and GCP, a VNet in Azure. Subnet-level firewalling is a NACL in AWS, an NSG applied to a subnet in Azure, and a hierarchical firewall policy in GCP. One quirk worth burning into memory. AWS subnets live in a single availability zone, while Azure and GCP subnets span an entire region. And GCP's VPC is global by default. That catches people. Learn one provider deeply, and the other two become a translation exercise. With the vocabulary aligned, let's put it to work in the architecture you'll build most often. The classic three-tier web app. Public-facing load balancer and WAF sit in the web tier, accepting 443 from anywhere. The app tier lives in private subnets and only accepts 8080 from the web tier's security group. And the data tier, RDS, cache, S3, only accepts 326 from the app tier. Notice the key move. Security groups reference each other, not IP ranges. So when your app tier auto-scales, membership updates itself, no firewall rules to chase. Now, before you go build, let's talk about where these projects actually go sideways. 5 pitfalls I see repeatedly. Overlapping sidars that make peering impossible. So plan your IPAM up front. NAT gateway bills that quietly hit 4 figures a month. Use VPC endpoints for ES3 and DynamoDB. And stop paying for traffic that shouldn't traverse NAT. Single AZ deployments that die with the AZ. Security groups sprawl, nobody can audit. And the peering trap where 5 VPCs become 30, and you're suddenly managing 135 connections. The fix there is simple. Move to Transit Gateway the moment you cross 10 VPCs, and design hub and spoke from day one. So let's pull it all together. Your VPC is an isolated network defined by a cedar block, sliced into subnets per availability zone. And going multi-AZ is what buys you real resilience. You've got 4 gateways to remember. IGW for internet, NAT for private outbound, VGW for VPN, and Transit Gateway as your hub at scale. Security groups are your stateful, instance-level workhorse. NACLs sit at the subnet, stateless, as a backstop. Peer for small, Transit Gateway past 10 VPCs. Direct connect when hybrid gets serious. And remember, Azure and GCP rename these concepts, but 80% of what you've learned travels with you. And here's your cheat sheet. Keep this one handy. Quick recall. VPC is your isolated network. VNet is just Azure's name for the same thing. And subnets carve it up per availability zone. Public subnets route through an IGW. Private subnets reach out via NAT gateway. VGW terminates your VPN. Transit Gateway hubs your VPCs together, and security groups guard each instance at the ENI. One glance, and the whole lesson snaps back into focus. That wraps up our cloud networking deep dive. Coming up next in Lesson 57, we shift from cloud constructs to the control plane itself, SDN and network automation. We'll get into OpenFlow, NSX, ACI, and how tools like Ansible and Terraform let you treat networks as code, the same way you've been treating cloud infrastructure here. Catch you in the next one over at dargslan.com or on YouTube.